So let's get started. Welcome to this lesson. Thank you for sending me a lot of the homeworks. I was glad to see that many of you didn't have severe problems in sending. Thank you, goodbye. That I was glad to see that not a lot of you, I think nobody really had big problems in setting up the prerequisites for Xamarin and Docker and so on. If you haven't managed to do it by now, please continue working on it because it's really important and we will definitely need it. Let me quickly check if the recording works fine. Does anybody have severe problems that he is not, that he has no idea how to overcome, or just problems where you know, okay, you have to continue working, or any, problem? Which one?
Just problems with my PC.
Okay.
Performance.
The PC is too slow?
Yeah.
Okay. Do you have the problems with Hyper-V or Xamarin or Docker or generally?
Xamarin.
With Xamarin. Okay. You might need to fall back to debugging Xamarin applications on your phone. Do you have an Android phone that's rather up to date? Maybe you can skip the emulator part and just try whether you can debug it on the device. The link to how to set up your device for debugging is part of the slides. So maybe you can try that one. If you don't manage to do it, please let me know, then we can try to solve it together in the next weeks, okay? Any other problems that we have to talk about, yeah?
Yeah, I also got problems with the Xamarin
with the emulator?
downloading the device data.
Downloading the device data.
Creating the devices.
I see. Yes, I know. Android device emulator is kind of tricky to set up if you don't have a pretty new and powerful PC. I know that. That's the reason why I mentioned that on-device debugging is fine too. So please, if you have problems with the emulator, try the path to debug on the device. Do you have an iPhone or an Android or Android? A rather new one or a pretty... Okay, then you can also try the on-device debugging. Okay? If you don't manage to set it up with on-device debugging, let me know. We still have a few weeks until we really need the Xamarin part. Okay? So don't worry. What you need today is just the installation of .NET Core 3 and Visual Studio 2019. Even if you have an older version, 2017, you will probably be able to follow along today. Okay? But in the next weeks, it will be more important. If you have the 2019 preview that I told you, then you are perfectly fine for today. Good. So, today we will jump right into the topic. It's mobile computing, so we will talk about web development and especially web API development. By the way, because I just saw the recording here, the recording of last week is already online. I created a new playlist in my YouTube channel, and the recording of today will also be online in a few days. Okay? Good. So today we are going to talk about ASP.NET Core. ASP.NET Core is a platform, and you have it here, for web APIs and web apps. At the beginning of this course, we will just focus on web APIs. We will not go into server-side rendering stuff. Maybe you can remember that from last year, and I have recapped that here. We have the distinction between server-side rendering, where you render the HTML on the server side, and you deliver ready-made HTML to the client, which is typically a browser client. But we are focusing on the different here, on the web APIs plus single-page apps or plus mobile applications. So in our case, we run the logic on the server and we generate JSON, JavaScript Object Notation, exactly like we did last year when we used Node.js and Express.js to implement web APIs. Okay? This is what we are going to focus here. The other thing, this here, is still relevant for some kind of applications, but currently not. Now, what is this ASP.NET Core? ASP.NET Core sits on top of .NET Core, and it makes it pretty simple to implement web APIs. I'm pretty sure you will like it. If you can remember what you had to do with Node.js, with all this npm init and install Express.js and set up a bunch of things until you get the first API running, none of this will be needed with Visual Studio and ASP.NET Core. You will see at the end of this lesson, you will be able to set up insert, update, delete, select APIs. It should be pretty simple, and the possibilities of errors is much lower than with Node.js and Express.js. Of course, you need a compiler and you need a development environment. The beauty of Node.js and JavaScript is that you just need an editor. You can immediately start going. But with ASP.NET.js, if you manage to compile your stuff and you have not written completely rubbish, it's very likely that it will run. Okay? So let's see whether it works. Last year, we spent the whole year talking about HTTP. So I guess you can remember HTTP get, put, post, delete, headers, URLs, query string parameters. If you forgot everything about HTTP and you say, hey, what is that? I've never heard about query strings, parameters, and so on. Maybe you should go back and take a look at the protocol, but I guess most of you can at least have some basic thoughts about HTTP, and you know approximately how it works. Good. So, let's get right into it. Before we talk about, instead of talking about theory, let's just try it. So, I ask you to follow along and spin up Visual Studio 2019. If you don't have Visual Studio 2019 and you just have 2017, if you don't have the preview or just the production version, I don't care. Just start the newest version of Visual Studio. I strongly recommend the latest preview of 2019, but it's up to you whether you have already set it up. Then we can create a new project. It's here. Pretty straightforward. Just click on Create New Project. And here in the project wizard, you can look for projects, and in our case, we are just looking for the project template called ASP.NET Core. And please look for this template. It says ASP.NET Core Web Application. It is in C#. It runs on Linux, Mac, and Windows, in the cloud, as a service, and on the web. It will be the backend for our mobile websites or mobile APIs. ASP.NET Core Web Application. Select it. Next. Please select any folder where you would like to store this stuff. Everything we do today is part of my slides, so you don't need to store this permanently. It's just for working today. I will put it in my temp directory and I will just call it HTL, I don't know, yeah, that's fine. Next. Oops, I already have a 27, so let's create 28. Good. Now, next we have to choose which version of .NET we would like to which version of .NET we would like to use. If you have installed the latest version of 2019 preview, you should see ASP.NET Core 3 here. If you don't have the latest preview, you should see ASP.NET Core 2.2 here. Take the latest that you have. I will show you .NET Core 3. I told you already, it's in release candidate currently. Upcoming Monday, it will become generally available, released to web. So until Monday, we have to live with beta software. On Tuesday, I think we can then use the production version. So I will use Core 3, but today, if you don't have Core 3, we don't wait for installing the new version. You go for 2.2. There will be slight differences, but most of the things just work. Next, we would like to select the API project template. The API project template gives you a basic setup for writing web APIs, and it's good if you want to get started and you are new to Visual Studio. If you would like to write a server-side application, you would probably use this one, but this is not relevant for us today. If you are an expert and you really know what you are doing and you want to configure everything exactly to the way you want it, you typically use empty and then you write all the code on your own. But hey, we are beginners, so therefore we use the API template. Please select API. Do not click on Create yet. We have to talk about the things on the right. The first thing, authentication. Authentication would be relevant if you want to protect your API. Not everybody should be able to call this API. I need a username and a password or a token or something like this. Not relevant now, maybe later. And in the advanced part, you can configure whether you want to use an encrypted connection, HTTPS, localhost something, or if you don't need encryption. We are just playing around, so we don't need encryption here, just remove this check. And last but not least, you have the possibility to enable Docker support. This will be relevant in this course, but later on. So now, clear the box, we are fine. Create. Then we have to wait a few seconds, and then we should have an ASP.NET Core Web API. Here it is. Now comes a very important part, and the next demo, I would like you to not follow along, okay? Because it's not very relevant for your exam and for your work, but I would like you to know that it is possible without Visual Studio 2, so I would like to show you something. So let's first start the terminal. By the way, there is a new Windows terminal, this one. It's a replacement of the CMD shell, and it works pretty nice inside of a nice new Windows. So if you want to do something in the terminal, so just here, terminal, then don't start just CMD, just start the terminal, and inside the terminal you have this button here where you can spin up a CMD, a command shell in Windows, and it also works with zooming and so on. Pretty nice. Give it a try, it really works nicely. So let me quickly create a folder, basic core demo, something like this. As I said, you don't need to follow along. This is just for your interest. It's not relevant for the exam. Let's quickly set up a web API in the command line. How do I do that without Visual Studio? Imagine that you found a company and you cannot afford to use Visual Studio because it's expensive if you use it for commercial purposes. Not as a student, but for commercial purposes. So you want to live without Visual Studio, no problem. If you have .NET installed, you can run the .NET command line interface, .NET, just like Node for Node.js, or Python for Python, or Java for Java, it's .NET. And then you can say .NET new. If you just say .NET new, I have to zoom out a little bit because the lines are pretty large, you see all the different templates that we had before visually in Visual Studio, now in the command line. And if we take a close look, there is a template which is called ASP.NET Core Web API. And that is exactly the template that we used in Visual Studio. But this time, I can use it in the command line. So I just say .NET new Web API. Of course, I could specify a lot of options here, all the options that we could interactively specify in Visual Studio, but I don't need to. I just take the default ones. Enter. And now it generates in a completely new directory the entire application. So, in a few seconds, we are fine. You see, this is the application, exactly the same application that we had before in Visual Studio. We will see later on in a few moments that a web API in ASP.NET Core is nothing more than a command line tool. So we can also start the web API. We don't need to start a heavyweight server like Internet Information Server or Apache or something like this. It's very similar to Node. Can you remember what we had to do in Node.js last year to spin up a web server? We just said Node, name of the JavaScript file, and the web server was built in. And the same is true here. You don't need to set up any kind of complex web servers. You just run the application and it runs as a command line tool. And therefore, I don't need Visual Studio to run it. I just say .NET run. If I do that, it spins up my ASP.NET Core web application, and here we are. It listens, in my case, on port 5000, and if I want to try it out, no problem, I just say localhost 5000 weather forecast. It's the name of the API in this demo application, and it gives me some data. It's just random data. See? So it runs perfectly fine in the command line. Now I could use Visual Studio Code, which is free and available on all platforms, to do some C# developing. I don't absolutely need Visual Studio for it. That's the point I want to make. It also works on Linux. So if I quickly... You don't need to follow along that, but we will do that sometimes later this year if we want to use, for instance, Docker. There is a Docker container, Docker image, sorry, which is called that. And I can spin up a virtual machine. It's not a virtual machine, it's Docker container by saying Docker run interactive, this one, version 3. This gives me a completely new Linux machine. No Visual Studio, no proprietary software installed, just .NET on it. So I can do exactly the same demo. Let's create an app directory, and let's say .NET new web API. But this time I'm on Linux, I'm in a Docker container, and it works exactly like on my Windows machine. And if I want to give it a try, if I want to run it, I do exactly what I did before, .NET run. And it will start the web server, it will start the web API, and it will just run inside a container. I'm done. So that's the beauty of having a command line tool. You're not bound to a heavyweight IDE like Visual Studio. You can do it completely on open source platforms with free software. That's the point I want to make here. Good? However, if you want to have a convenient life, and if you want to have nice visual assistants helping you in writing code, stick to Visual Studio. You get it for free, and even if you are out there and have a small company, you can get it for free and use it for free too. Only for larger companies, for commercial purposes, you really need to buy a Visual Studio license. Now, how do we work with that in Visual Studio? The simplest thing is to just try it out. I could press play here and it would run. However, first, we need to look into what Visual Studio offers us here. Oops, let me zoom differently. This is what I want to show you. Before pressing the play button, I would like you to recognize that there are 3 different options here. We can use IIS Express, we can use Web Application 28 and Azure Dev Spaces. The first one spins up an Internet Information Server, but I already told you that for ASP.NET Core, you don't need an Internet Information Server. So if you want, just ignore the first one. It's not relevant for, or not necessary for the things that we develop here. There are some reasons why in practice you might consider an Internet Information Server wrapped around your ASP.NET Core app, but that are advanced scenarios that we don't cover in this course. The last one, Azure Dev Spaces, it's relevant if you work in a larger enterprise, you work with Docker containers, and you have a system which is called Kubernetes. Have you heard about Kubernetes before? Maybe in your intern work or in larger companies or in another course here. Kubernetes is a pretty large Docker infrastructure, and only very big companies have Kubernetes clusters. It's hard to set up, it's hard to maintain, not everybody has it. We don't have a Kubernetes cluster here in this course. We also will not cover Kubernetes. If you are extremely interested, I can show you a few demos if you want, but in most cases we will not need it. It's too large for our purposes, so you can also ignore that one. The thing that we really go for is just running the application as a command line tool. So please do the following. Click on the name of your application. By the way, you don't need to follow along, just for your interest. I can go to Properties, go to Debug, and there I have these profiles, and if I want, I can delete the profiles that I'm not interested in. So if you want to get rid of them, delete them, but you can also just ignore them. If you have it, press F5 or press play, and the application should start in Visual Studio in the debugger. You see, it's a very simple command line tool. It's just there. It starts the browser, it hits your API, and it returns some data. Just F5 and you're done. Does it work? Yes? Good. Good, good. I would like to spend a little bit more time on this line here. This is not relevant for your exam, but still I would like you to understand what this means. Let me quickly take the camera so you get a better picture of what I'm going to draw here. Can I place it here for a second? Good. Something like this, and good. Something like this. Now, let's quickly talk about what a reverse proxy is. Can you remember from other courses what a proxy is? What is a proxy in terms of networking? I'm sure you know that. Don't be shy. So what is a proxy? Can't remember what a proxy is? Let me tell you. If I have my client computer here, and here is the big wide internet, and this client computer here is sitting on an enterprise network. For instance, you work in a larger company and you would like to access the internet. You typically, in many cases, are not allowed to access the internet directly. What these companies do is they set up a proxy in the middle. Your Internet Explorer, no, not your Internet Explorer, your Chrome, your Firefox, whatever, or your mobile app connects to the proxy, and the proxy then connects to the internet. Why would any company invest time and money in setting up such a proxy? What do you think? Can you come up with any idea? Yeah?
They can filter traffic.
Exactly, they can filter traffic, they can install detection mechanisms for malicious software or viruses and things like that. That's the reason for a proxy. Good. So guess what? What is a reverse proxy? It's exactly the other way around. Imagine you have the big wide internet. Here you have your server with your API, could be an ASP.NET Core API, and somebody comes through the internet and would like to access the API. It's exactly the same concept. You prevent accessing the API directly. Instead, you set up here a reverse proxy, because it works the other way around, not going out into the internet, but coming in from the internet. So all the internet traffic is redirected to the proxy, and the proxy then calls your API. Why would anybody set up such a web reverse proxy? Well, the same reason as you set up a proxy. For security reasons. To filter, for instance, incoming traffic. To make sure that nobody sends malicious requests. Can you remember from other courses what a SQL injection is? Can you remember that? Could you describe it? Should we quickly recap it? Because it's important. Security is also an important thing here. Let's quickly think about what we learned already about SQL injections. Think of, for instance, the login screen where you have a username and a password. In your code, you write something like if blah 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 select star from users where username equals, and then you copy the content of the input of the user into your SQL statement. That is a SQL injection. Because you know what I would do? If I would be an attacker, I would enter here something like closing quotes, semicolon, drop table. You would copy this into your SQL statement. It would closing quote, semicolon, drop table, something, and I can destroy your database. Get the idea? Then we have a big problem. So this is called a SQL injection, and you should never ever write code like that. Never ever write code where you build any kind of executable code like SQL statements by string concatenation. Never do that. That's a very bad sin. And guess what? These reverse proxies have firewall capabilities. If you buy the right reverse proxy, or there are cloud services which you can rent for only a few bucks per month. If you rent the right reverse proxy, you can add a so-called web application firewall, and this web application firewall would detect something like this and would block incoming requests that try to execute SQL injections. So it's a kind of extra level of security. If we are not completely sure that we covered everything in our code, we can add this extra level of security. This is why in real world, many people or many companies, especially in the cloud, set up reverse proxies or so-called API gateway. You mean the same, they mean the same, okay? They set up an API gateway in front of an API to do security checks like that. For simple APIs, it's not absolutely necessary. If you are not a commercial provider and you just try something in this course, we don't need an API gateway. But if you think of founding your own company and offering a public API and you are afraid of hackers, you should really consider setting up something like this. And nowadays, luckily, you don't need to set up and maintain these things manually. You just rent them in the cloud. There are many cloud services providing such services, and they don't cost a fortune. Got it? Good? Good. This is not relevant for your exam, okay? This is just for your interest. I will always tell you when we cover something that is relevant for the exam. Good. If somebody tells you that for ASP.NET Core you always need a reverse proxy, that has been true in the past, but it's no longer true. ASP.NET Core runs perfectly fine directly connected to the internet with all the problems that I just mentioned. Good. Oops. This one. So this is just the drawing here, just what I draw on the blackboard. Good. Next one. Let's take a look at the code. First, let's take a look at the project file. The so-called csproj file. It's called csproj because the extension of the file name is called csproj. The csproj, the config file in ASP.NET Core is pretty clean, as you can see it here. You could even delete these 2 lines if you don't like them. They are not necessary now. So this is a big difference compared to previous versions of .NET. Have you ever taken a look at, I don't know, a WinForms csproj file? Nobody wants to look at this stuff. It's horribly long, it's complex, nobody wants to maintain this stuff. It's not really nice. In good old .NET Framework applications, you also had many so-called NuGet package references. Do you know what NuGet is? If you don't, remember what we did last year with npm. We had this npm install this and npm install that. The analogy of npm in the C# world is called NuGet. Okay? Do you see any NuGet references here? No, because especially with .NET Core 3, the project file has been cleaned up. Microsoft has learned that many developers always struggle with the same things. It should be enough to specify, hey, I would like to use this version of .NET Core and I would like to do web development. That should really be enough. Just give me all I need. And that's the idea here. So the csproj files in ASP.NET Core are simple, they are straightforward, and I have even a better news for you. You can leave it as it is. For nearly all of the exercises that we do, just ignore the csproj file. Visual Studio will maintain it correctly for you. You can take a look if you are interested in, but you will never manually do something with it. That's a big advantage compared to Node.js. Can you remember how often you took a look in package.json and the different NuGet packages and so on? Much simpler here. Okay? Good. Because we have an IDE, and nevertheless, I can tell you in more complex scenarios, if we work in real world, of course, you often take a look in the csproj file and you have to do some changes, but still, it is much smaller and much easier to handle than compared to previous versions of .NET. Good. Next one. The next one is the program CS. I already told you that an ASP.NET Web API is nothing more than a command line tool. So therefore, there is a main method. A main method, just like in Java, just like in many other programming languages, like in C++ and so on. Here, everything starts. And what does this main method do? It calls another method down here, and this method essentially calls this one line. For this course, this line is perfectly fine. It essentially says, give me a host for my web server and configure it with the default settings. Of course, in more elaborate scenarios, if you work in real world, the default settings might not all be perfectly fine for you. So you would dive deeper and you would change the default configuration. But to be honest, the default configuration pretty much makes sense. So for this course, we are fine with that. All we need to do is we need to tell the default host where our program starts. And for starting up an ASP.NET application, all we need to do is we need to create a so-called startup class. This is what we have to write. So to make a long story short, for this course, the program CS just works. Maybe at the end of this year, maybe we will do some minor changes here. I'm not sure how far we will get, but currently leave it as it is. It just works. It spins up to your web server and it will run. That brings us to the first file, which is really relevant for us, the startup CS file. The startup file contains 3 methods. The constructor, the method configure services, and the method configure. Now, can you remember what a constructor is? It is a method that runs automatically whenever an instance of the class is created. So whenever somebody creates a startup class, the constructor runs. ASP.NET Core will create exactly 1 instance of your startup class. So the constructor runs once. Good? Now, the configure services method, we can leave it as it is for the moment. We will talk about it later. I will not discuss it. The interesting guy here is the configure method. And I would like to spend a few minutes describing in more details how this configure method works and how ASP.NET Core works behind the scenes. This information, how it works behind the scenes, is just for your interest. Maybe you should understand the basic fundamental principles. You will not need to code it like that, like I will do it now. But still, I would like to show it to you, and in an oral exam, for instance, in a theory exam, you should at least describe the basic fundamental building blocks. So, the next lines of code that I will write, please do not follow along, okay? It doesn't make sense. Just follow along in your head, try to understand the concepts. You will probably never write this code, at least not in this course. Let me quickly comment out the thing that was auto-generated. And let me quickly hide this one. We will show it later on. Hide selection. Good. Good. Now, let me describe how ASP.NET Core works in the background. And again, I need to do some drawing here. Do we have a second one? Yes. Good. Let's do it this way. Think of the following scenario. We have a client, can be a mobile client, can be a desktop client, can be whatever. Here, we get an HTTP request. At the end, we will return an HTTP response. And here, we have our API. Now, how does ASP.NET Core works? It uses a technique which is called a request pipeline. Think of it like a complex network of fluid pipelines, an oil pipeline, like in a refinery or something like this, where you have oil running through different pipes which fork and which come together and things like that. ASP.NET Core works in a similar way. What you essentially do in ASP.NET Core, you use so-called middlewares. You just, in C# it's just a function. You just plug in functions and you chain these functions to this pipeline, okay? One function after the other, and at the end, well, there is nothing. At the end is nothing. And each function takes a look at each incoming HTTP request. It inspects the HTTP request and it asks itself, is this relevant for me? If it is, it can, for instance, generate the response. If it is not relevant for this part of the pipeline, it will just forward the request to the next function. Then the next function runs and says, is it relevant for me? Should I generate the response, or do I just hand it over to the next one? It is also possible that the first function builds a little bit of the response and still hands it over to the next one and says, hey, next one in the pipeline, do you want to add something? Get the idea? What could that be? Imagine the following situation. Here we have a function which does authentication. It takes a look at the HTTP request and says, the user that sent me the request, is he allowed to send a request? He can take a look, this function can take a look at the HTTP header, or can take a look at a token, verify a password, or do something like this. If the authentication is okay, it will hand over the request for further processing. If the authentication is not okay, it can return a forbidden error, for instance, or something like this. Get the idea? The next function could take a look and say, okay, the user wants to have a file which is called index.html. Do I know what index.html is? If yes, I will return it. If no, well, maybe somebody else knows. I give it on to the next pipeline element. Get the idea? So let me show you how that looks in code. The code that I'm going to write now, you don't need to follow along and you will probably never write it like that, okay? app.use. Let's do an async method which gets a context and a next pointer. And then we go on and say await context response, write async, something like this. Hello, good. Here, I'm missing a using. Let me quickly add that using, and then I say await next. So what essentially I'm doing is, hey, I would like to send a response, hello, and then I pass it on to the next one, and the next one can also add something. So I can add another element in the pipeline, like this, and this second guy says world, and passes it on to the next guy. The next guy can say, I'm the last one. In this case, I'm not using use, but I'm using run. Async context, I'm not getting a next anymore. And here I just say, for instance, something like this, exclamation mark. So what we see now here is we see exactly what I've drawn here. We have one element in the pipeline, passing it on to another element in the pipeline, passing it on to another element in the pipeline. And each incoming HTTP request will run through the entire pipeline. And if nobody cares for this request, not found will be returned. Get the idea? Of course, I can do an if statement here. If context.response.headers, something like this, and then I can do some conditional statement, and I'm passing on the control only if some condition has fulfilled. You get the idea, right? Good. Let's remove the if again. Give it a try. So let's run it. And set a breakpoint here. Good, it's running. Let's set a breakpoint, another breakpoint, and another breakpoint. Let's go here and do something like something. Now we have the HTTP request and it's coming in. And now I can take a look at the context and I see the request and I can take a look at the URL, for instance. You see this /something here? So I can take a look in the incoming request and decide whether it's relevant for me. If it is, I send something back and hand over the control to the next one. I send something back, hand over the control, I send something back, and so on and so on. I think you get the idea. And if I take a look, the result will be hello from the first middleware, world from the second one, and the exclamation mark from the third one. This is how ASP.NET Core works. It takes an HTTP request and just passes it on to a list of functions. And each function can contribute to the result. Do you get the idea? Good. The good thing is that we don't need to write all these functions. They already exist. So the good news is we can just get rid of this guy and take a look at the code that was generated for us, and now I'm back in your world, and you will see a bunch of use statements. And whenever you see such use statements, you now understand that every single use statement is such a middleware function that you have seen me writing in this simple use and run stuff. Okay? So in real world, if you are not deep in the technical details of ASP.NET Core, you will probably not write this use and run statements on your own that I did. But you will probably just use these ready-made middlewares. And there are many, many middlewares here. For instance, there is a middleware, I have it in my slides too, there is a middleware which can just return static files. Files in your file system. It says, okay, if I find the file, I will return it. If I don't find the file, I will just pass on the control to the next element in the pipeline. Again, you don't need to follow along this example. I would like to show you this example here. I have prepared it. It's linked in my slide deck. It's part of my GitHub repository. So you can easily try it out at home. You see, static files. Static files means it takes a look in a folder. This is a regular file system folder and looks for files in this folder, index.html. So if I run this guy, let's see. It will come up in a second. Come on. Here it is. Localhost 5000 something. If I specify index.html, then I will get the content of the HTML file. But if I specify something like hello world / anything, I will get back hello world. Now let's take a look at the pipeline here. The first element in the pipeline is this one. The request comes in. The first element in the pipeline asks the question, do I have the requested file? In my case, index.html. If yes, if I have the file, I will return index.html. If no, if the user asks for something strange where I don't have a file with that name, I will just pass the control on to the next element in the pipeline. And this is my element down there. In this element, I'm asking the question, did the user request something from the folder /hello world? If yes, I'm answering with hello world. If no, I'm forwarding the request and there is nobody to forward the request to. So guess what? If I'm asking for a file which does not exist and which is not in hello world, I will get a not found error because nobody in the pipeline is interested in that request. You get the idea? So here I've combined a custom middleware and a middleware that already exists, which just delivers static files. You get the idea? Good? Very good. So what do you have to remember from all this stuff? You have to be able, in an oral exam, when we are talking about theory, to answer a question like, describe the basic principle of a pipeline in ASP.NET Core, and you should draw something like this. But you don't need to write this lambda function stuff with this async await and use and run and so on. This is not something that I ask you to do. Because maybe you will be able to do it at the end of the year, but I think you should at least understand the basic principles. Even in real world, you rarely write code like that. You typically do more application level stuff. Good? Fine? Nice. And with that, we can go back to the example that was generated. And I think we are nearly at the break, right? Perfect. And we are perfectly in time because now we can, after the break, we will continue with the things that were generated and we will switch gears and forget about the startup code because it was auto-generated and essentially it's fine. And we will start working on controllers, okay? Good. So enjoy the break. Welcome back. Let's continue with ASP.NET Core, and from now on, the whole lesson now is very relevant for the rest of this year, and it's also very relevant for your exam. So in the first hour, a lot of conceptual stuff and a lot of for your interest, but the things that we do now, you will definitely need them in your exam. So let's write a little bit of code together, and I would really ask you to follow along from now on. The first thing that we would like to do is we would like to change the existing controller. You can find it here in the subfolder controllers, and the template in Visual Studio generated a controller for you which is called Weather Forecast Controller. Before we change anything to this class, let me quickly describe what a controller is. A controller gathers together all C# methods that implement, let's say, a set of logically connected web APIs. For instance, if you are building a CRM system, a customer relationship management, you might have a customers controller that handles all insert, update, delete, select for customers. You might have an orders controller that handles orders, an order details controller. You get the idea. So you put together things that logically belong together in a single class, and we call this class a controller. The first thing we are going to do, because we are building a different sample here, we are going to rename the controller. How do you rename a class in Visual Studio? Just set the cursor inside the class name, press F2, and call it to-do controller. To-do controller. To-do items controller. It doesn't really make a difference how you call it. To-do items controller. Okay? And we don't want to have the default code that was generated for us, so please remove everything, so our class, as you can see it here, will be empty. We will write that code on our own. To-do items controller, controller base. Now, let's take a closer look at what this controller, how this controller class is built. First, please recognize the base class, controller base, as you can see it here. The controller base class marks this class as being an ASP.NET Core controller. That is the point that you need to make. You absolutely need to choose this base class. If you remove this base class, your whole ASP.NET Web API will stop to work. ASP.NET Core will look for all classes that derive from controller base. So please remember that controller base is the base class for all API controllers. Additionally, to tell ASP.NET Core that we really want to write a web API, we need to specify up there the attribute API controller. Now, what's an attribute? Have you heard attribute in C# before? Maybe. In TypeScript we had something that was called a decorator. I think in Java you have something similar too. I'm not good in Java. How is it called in Java? Annotation, exactly. So what does these annotations or attributes do? Do they change the way the class is compiled? Yeah?
They implement the code without you having to write the code.
It's kind of true what you say. The point is they don't implement code. Yes, they influence how the code is executed, but they don't implement anything. An attribute is just as the name suggests, an attribute on the class. It's passive. It doesn't do anything. It doesn't generate machine code or intermediate language code. But this attribute can be interpreted by somebody. Have you ever heard the term reflection? Reflection API? Maybe. Reflection, like in the German word Reflexion, introspection, if you want like this. I'm thinking about myself. An application can ask questions like, which classes do I consist of? And when this application uses the Reflection API, it can ask questions like, okay, which classes do I consist of that have the attribute API controller? And then ASP.NET Core can handle this class differently depending on whether this attribute is there or not. So it's interpreted at runtime, and this is why I said kind of true. It is not compiled at compile time, it is interpreted at runtime. So it doesn't generate code, but it influences the kind of processing of this controller class. For our case, to make a long story short, just remember, put the API controller attribute on top of your API controllers and you're all good. Good? Next one, route. The route attribute specifies where the controller should be available in terms of HTTP path. It's easier to demonstrate what I mean, okay? If I enter HTTP localhost something like this, slash to do items, then this would work. Why? Because you see here in the braces you have the word controller, and that means use the name of the class without the word controller at the end. Therefore, to do items maps to do items. You get the idea? But you don't need to write it like that. You can also say something like, and please do that, API to do items. If you do that, the controller will be available at to do items and API in the front. Get the idea? This route will be mapped into the URL under which this controller is available. Clear? Not difficult, is it? Good. Nice. This is how it should look like. Now we can start writing some code. Please open in my slide deck the slide 3/17. The headline says Web API simple get all. Chapter 3, slide 17. And then just copy the content of the controller class. I mean this part. And copy it into your controller class. It should just work. We will take a look at every single line of code, so bear with me. Good? Good. Now let's analyze the code that we have just copied. First, we add a list of string. Now let's analyze that. Private. What does private mean? Let's quickly recap some C# basics. Private means the list of items is available, is accessible from where? Only this class. Exactly. Only the to-do items controller can access the items. Static. What does static mean? That's more difficult, right? Yeah? Do you know it?
Yeah, you can call it without creating an object.
You can call it without creating an object. Yeah, you can put it in different terms. You can say there is no need to create an instance of the to-do items controller. There is just a single items list for all to-do items controllers. Even if there is no to-do items controller, the item list always exists. That makes sense, right? Because we have many items, to-do items controllers. For every HTTP request, we get a new to-do items controller. But the list of items should be kind of database. In our case, it's just in memory. It's not written on disk. But still, there is only one database. So this is what static does. And read-only, well, kind of obvious, right? Read-only means I can only assign this value once, and afterwards, I cannot change it anymore. I mean, that's clear. And what do we add? We add clean my room and feed the cat to this list of string. Okay, should be clear. And now we want to make this list of strings available through a web API. And it's surprisingly simple because you need to do the following. You just add a function. You add the attribute HTTP get. Get here refers to the HTTP method. Get, put, post, delete, patch. Can you remember that? HTTP get. And all you need to do is you need to return the HTTP status code, OK, HTTP 200. You can remember the status codes? 200, OK, 201, created, 500, internal server error, and so on and so on. And give it the content that should be returned. And in our case, it's just the list of to-do items, the list of strings. Pretty straightforward, right? You can even make the syntax a little bit cleaner. That's not absolutely necessary, but for those of you who dislike the word return, you can make it a lambda, an expression-bodied member, something like this. Looks kind of cooler, but hey, I don't care. It isn't better, it isn't worse. It's just a matter of taste, whether you want to write the return or you don't want to write the return. It's just a short form, that's all. Pretty simple, right? And the return type of the get all items is typically iActionResult. We will learn about different return types, but for the moment, it's just iActionResult. iActionResult simply says it is an HTTP status code, okay, bad request, things like that, plus the content. And we are done. It already works. Let's give it a try. Run it. You can run it on your own. If you are in the command line, .NET run. If you are in Visual Studio, just press F5. Then your app should start running. My laptop is a little bit hot. When it gets hot, then it's getting slow, unfortunately. So, and if you just say API/to-do items, you should get a list of to-do items, namely, clean my room and feed the cat. Does it work? Pretty simple, right? Compare that what we had to do in Node.js. We had to do npm init and npm install express.js and create a server.js and do require statements and then manually somehow parse the request and do a manual JSON serialize and whatever. All the things, we don't need them in ASP.NET Core. I'm not saying that Node.js is a bad system. By far not. I love Node.js. But the rule, simple things must be simple and complex things must be possible, they work perfectly fine here in ASP.NET. Simple things are really simple. Of course, when you have to build more complex stuff, it gets equally complex as compared to Node.js. But the simple things are really simple. That's good. So, should be clear, right? Good. Next one. Just go back to the slides. Go to the next slide, to the next slide, and again, copy the code and append it to your controller. Something like this. This is the code that we are now more interested in. Once you have copied it, let's quickly analyze it. By now, you already know what this HTTP GET is all about. I don't need to recap that. I think you understood it. But now we have something new. First, please note that in the route statement, we have these curly braces here. These curly braces mean that part of the route is variable. You see, index refers to this parameter here. So, if we enter the following URL, http localhost 5000 API to do items /42, then the system works as follows. The first part, API to do items, is recognized because of this route up here. Get it? This one. And the last part here, this 42, is now recognized because of this route here, index. And this 42 will then be passed into my method using the parameter with a name index. Get it? Pretty simple. All we have to do is we have to check whether the index makes sense. Is it greater or equal 0? Negative indexes don't make sense in a list. Is it lower than the number of items in my to-do list? If so, we return a single item on the index n. If not, we return bad request. This is the HTTP status code, but you don't need to remember the HTTP status code. You get IntelliSense, you see? You just write bad, and if you can't remember it, you immediately get IntelliSense, so don't worry, you don't need to remember that all from the top of your head. IntelliSense is your best friend. And here, we just say error message. Let's give it a try. Press F5, run the debugger. And just to give it a try, okay? When your app is up, when you started it, don't immediately enter the URL. Wait a second. And first, go back to your Visual Studio and set a breakpoint here in this line. You can do that by clicking in the gray area here on the left-hand side, or by clicking F9, set breakpoint. Once you've done that, try it. Say localhost whatever, API, to-do items / index1. Enter. If you do that, Visual Studio, give me a second, Visual Studio should break, and you should now see that you got the index 1, and you can now step through your code and easily recognize mistakes, errors, or whatever you did. It's easy to debug. If you want to continue, just press the green continue button up there, and it will run through, and you see, index 1 is feed the cat. That's exactly what we wanted to have. You can remove the breakpoint again and try it with different indexes. 0, clean my room, works good. And if I say 42, there is no item 42, I get the error, invalid index, bad request. You wanted to ask a question.
How do you set the automatical domain when you start the program?
Which domain? What do you mean?
It first opens the browser as...
You mean the weather forecast stuff? Yeah, that's easy. That's a good question. How do you change the URL? Is it that you were asking for? You can just right-click on the project, go to Properties, and please make sure that you stop the debugger before you do that, because otherwise you can change the settings. And here, you see, you have the app URL. You see that one? And here, you see, you have this setting launch browser. See that one? So if you want to change that, you can easily change that to API to do items or whatever you want. Does that answer your question?
Yes.
Good.
Thank you.
Good. Do you get the idea how this works? Difficult? No. Once you got used to it, it's really straightforward. Next step. Next slide. Same drill as before. Copy the code. This time we are at the simple add method and append the code here in your C# file. And then we will take a look at this code that we just copied in. Please recognize that we now don't have a HTTP GET, but we have an HTTP POST. Can you remember from last year what HTTP POST is? It's an insert. We add a to-do item. This is why we call the method add item. I mean, kind of clear. The important thing is this one, from body. From body means, hey, please ASP.NET Core, take the new to-do item from the HTTP body. If you can remember what we had to do in Node.js, we had to manually get this stuff out of the HTTP body and things like that. We don't need to do that. Just apply the from body attribute and we're fine. The only thing we have to do is we have to add the item. That's all. That's all. A little bit special is this created at route. Can anybody remember how we did that in Node.js? We sometimes return the created response code. It's 201. And with the created response code, I often asked you to also return the so-called location header. It's like a street sign pointing the caller to, hey, you just added a new item. If you're interested in, you can read the item that you just added at this URL. It's just kind of being polite. It's optional. You don't absolutely need to return that, but you can, and it's kind of best practice if you want. And please note that this here, get specific items, refer to this name up here. Get it? So we just say there is a route which is called get specific item, and you can query this thing with its index from this route. That's all. Again, it's optional, but it's good practice. Okay? Let's give it a try. Run it. Now, once we run it, we need to somehow send a post request. And we cannot do that in the browser. Maybe you can remember from last year, Postman, or Insomnia, or REST client. Can you remember these things? I created that for you and to make your life a little bit easier. If you want to follow along, you can also just watch me doing it on the video beamer, but if you want to follow along, go to slide 15, 315, and there you have a link to the demo requests. If you open this link, you will get a REST client compatible list of requests, and you can copy them out. You don't absolutely need to do that. If you want to follow along, copy it, but you can also watch me doing it. Believe me, it really works. And then I open the folder in Visual Studio Code. You see, I just say open with code. Unfortunately, there is no similar REST client in Visual Studio. The REST client of Visual Studio Code is really the only one that is as good as we need it. We just create a file. Let's call it, I don't know, requests.http. Oh, my laptop is getting so hot and so slow. We will. Hopefully it will survive. I really hope so. I will open the window. Maybe it makes it. Don't laugh, okay? I have an expensive laptop and I need to open the window in order to make it run faster. It's kind of crazy, but these small laptops, these thin laptops are horrible when it comes to temperature. Good. If we want to run it, you see the GET request, just click on Send Request. This is the REST client. Please remember what we learned last year. If you click on it, oh, my port is 5000. Sorry. Again. And we get back, clean my room, feed the cat. And now please take a look at this one. Post, and here, watch TV. If you want, you can go to Visual Studio, set a breakpoint here in the add method, and here, do the add. Jump into Visual Studio, this is done automatically, and if I hover over it, you see watch TV. So I didn't have to do anything, the body of the request is automatically transferred into my variable and I can immediately process it. Got it? Good. So, continue. If we have it, watch TV, and if we do the get, we now have 3 items. Hooray! That's exactly what we wanted to do. Good. So, stop the debugger. Any questions regarding the add method? Not really. Pretty straightforward. So, next one, I think it's the update, right? Yes, it's the update. Here we have the update. Same step as before. Please copy the code. Copy. Please add it to your controller. And then we will discuss the update code. Here it is. Please note that now we have an HTTP put statement here. And now we are combining, that's the interesting thing here, we are combining the route parameter with the index and the from body attribute because we want to update a specific item. We need to specify which item, the index, and we need to also specify the new content of the item from body. While the rest is trivial. Check the index, if it's okay, update the item and return okay. If the index is not okay, return a bad request. I will not execute this because believe me, it really works. This is the request as it would look like in the REST client. You see, put, you specify the index, and in the body, you specify the new content of the element. Get it? It's nearly boring, so easy. Yeah. Will become a little bit more complex later on, but currently it's a good thing that it is boringly easy. Last but not least, delete. Same drill as before, copy the code. And let's analyze the code. I don't even want to say anything to it. Just take a look at the code and I guess it's clear. Right? Note the delete here. The rest, business as usual. Nothing special. Great. Now we have a web API with which you can get items, get a specific item, insert an item, update an item, and delete an item. That's pretty cool. That's a basic web API that is already useful. Okay? However, it's a little bit too trivial because what we do now is we are currently just maintaining a list of strings. And that's a little bit too trivial because in practice you don't maintain a list of strings or ints or dates. You typically maintain a list of business objects like a customer, an order, or the details or something like this. Huh? So let's switch gears and make it a little bit more interesting by adding, this is not important now, by adding a DTO class, a so-called data transfer object. Please copy this to-do item class, this one, or the whole, we put it in the same file. Copy the class, the whole class to-do item, and put it in front of your to-do items controller. You can also put it in the back, but not in the middle of your to-do items controller. It should be somewhere outside the to-do items controller. And you should get a bunch of errors here. And these errors are not a coincidence because we have to specify a so-called using. Can you remember in TypeScript, you always had to generate this import statements at the beginning of the file? In C# it's exactly the same, but it's not called import, but it's called using. And if a using is missing, you typically get this light bulb here. See that one? Click on it, and then Visual Studio can generate the using for you. If you don't want to click with the mouse, you can also use the shortcut Ctrl-. And then you can also generate the using. And then the errors should go away. Now, this to-do item here is a data transfer object. Data transfer object, or short DTO. A data transfer object is used to transfer data of a certain structure. So we specify the format through which a to-do item should be transported to our web API. And please note the so-called data annotation attributes up here. They are so useful. What you can define here, you can define some business rules, which fields are mandatory, they must appear in the payload, for instance required. You can specify a minimum length, a maximum length, you can specify a minimum value, and many, many things more. I have a list of all the data annotation attributes in my slide deck. And the great thing is that you don't have to check that. ASP.NET Core does that automatically. If somebody sends you a to-do item without a description, ASP.NET Core will recognize the required attribute automatically and it will return an error. You don't have to care about it. In Node.js, we had to write code for that. No longer in ASP.NET Core. It is just automatically out of the box. So what do we have to change in our controller in order to make it a list of to-do items? Well, first, we need to change the collection from list of string to a list of to-do item. And of course here we also need to new up a list of to-do items. Now our to-do items are a little bit more complex, so we cannot just say clean my room. We need to change that a little bit. We need to say new to-do item description equals to clean my code, clean my room, and assigned to equals to me. And I'm happy with that one. I'm just adding one example. So it should look like that. Get it? New list of to-do item, And then you can specify just a to-do item with a description and an assigned to value. Good? Now please note in Visual Studio these small little ticks here on the right hand side. You see that one? You see? Bless you. You see these 3 red ticks? They indicate errors. So we can just scroll down to the red ticks and we see, oh, here. We have a new item. Previously it was a string. What is it now? A to-do item. And this small change is really the big news for you. Let's quickly think it through. We just say, hey, ASP.NET Core, now I don't get a string, I get a complete to-do item. Please take the thing that the user sent you and transform it into the DTO to-do item. All the sanity checks, like is it JSON, has it a description, is the description of the required length, and things like that are all done automatically. You don't need to do anything by hand. This is called modal validation. You can find more information about that in the documentation, but currently I think you just get the point. We have a last tick here, of course, because again, from body, let's change that to to-do item. And all our ticks are gone. That's good. That's good. Now let's give it a try. Let's run it. Be patient if you have a laptop like mine. Good. And look what happened. Description, clean my room, assigned to me. It just worked. Get the idea? Now let's try the modal validation. I have prepared additional requests here. Let me show you what I mean. Here I have a post request. I don't need the advanced here. If I want to add something, I can just send a post request, and here I just specified JSON. It has a description, it has an assigned to, so the content should be valid. Let's try to insert that. And you see, we are here in Visual Studio, and if I hover over this guy, you will see I have it in the debugger. I can take a look at the item, I can step through my code, and if I'm happy with it, I press continue. And that adds exactly all the items that I want to have. And now comes the important part. What if we send something that is invalid according to our business rules? Please note that our description consists of a single letter, X. If I am allowed to refresh your mind, here we had a min length statement. You see that one? So if I click on that, boom, we get an error. Did we have to write code to return a bad request? Did we have to write code that gives the meaningful error message, the field description must be a string or array type with a minimum length of 5? No, we hadn't. This is done by ASP.NET Core automatically. And this is a great value. It gives you a lot of productivity because you just specify your data transformation objects and you're done. And now think one step further. This class here. Imagine you have to write a mobile app for your iPhone. You will need this class in your Xamarin code because you will have a form on your iPhone or on your Android where you enter this stuff. And guess what? You can reuse this class. If you use C# also on the client, we can reuse this class. And you can also reuse all these sanity checks in the UI. So if you have an input box on your iPhone and you don't enter at least 5 letters, you will get an error already in the view when doing the data binding. So this is a big advantage when you use one platform on the client and on the server, because then all these business rules, these checks and so on, They work on the client and on the server without you having to write additional code. I see many companies using, for instance, C# on the backend and Swift on iOS and Kotlin on Java. They have to write a lot of code 3 times. So there is a value in using a single framework and a single platform on the client and on the server side. I know there are disadvantages too. I'm fully aware of that. But I want to point out that there are advantages too. Do you understand what I mean? Good. Good, good. Any questions so far? Nope? Good. Last but not least, I have one thing that I don't want to try because of time constraints. I just want to show you. Imagine that you have a URL where you have a query string parameter. You know what a query string parameter is? That was the thing with the question marks at the end. Sorted question mark, sort order ascending, for instance. If you have something like this, you don't use from body, but you use from query. That's all. And then you see sort order, sort order. You will automatically get the sort order in your C# method. Right? Good. And that's about it for a basic so-called CRUD, create, read, update, delete, for a so-called basic CRUD service. It should be easier than Node.js. A little bit easier at least. The simple things are really simpler. The complex things aren't always simpler, but the simple things are. I would like to give you, or not like, but I give you a homework that you can work on and try these things on your own. I've already entered the GitHub Classroom link in Webuntis, okay? So please take a look at it and let's quickly discuss what's part of this homework. Essentially, it's an API. It's a contact list API. You can add people, you can remove people, you can get all people, you can find people by name. If you take a look at this Webuntis link and you just follow it, then you will see that I have specified the details of the API using Swagger. Can you remember from last year? Swagger, Open API, the strange WAML stuff? Here you have the Swagger WAML file, and the simplest thing is to just copy this into your clipboard and then follow the link that I gave you here, Swagger editor. Here it is. And then, once the Swagger editor is open, you just paste the WAML file into this UI here. And then you see on the right-hand side all the methods that you have to implement. Get, post, delete, and get with a find by name. This is what you should implement. Very similar to what we did today, but with a little bit more complex data structure, and there are small gotchas in this exercise, not big ones. I primarily want you to recap what we did today. So what are the rules for this exercise? Rule number 1, everybody has to come up with his or her best try, in your case, his best try. And you can get an extra point if you finish this homework. So if you implement all the requirements in the Swagger WAML file, just send me a GitHub issue and I will take a look at your code. And if I also think that you implemented all details of the API, you will get an extra point. Please use C#. Please use ASP.NET Core 3. If you still have many problems with Visual Studio 2019 preview, then okay, I accept 2.2 also, but this is the last time that 2.2 should be okay. Question?
Do we also have to add some classification now, like not names and stuff? Okay, we could. This
should be. No, it is not done by Visual Studio automatically. Yes, of course, git ignore, yeah. If you don't want to write the git ignore file by hand, just go to gitignore.io and enter Visual Studio. Here it is, Visual Studio. And then hit create, and this is the perfect file for Visual Studio. Just copy paste into git ignore and that's it. That's the most simple way to generate it. There is no node modules file folder anymore. Yoo-hoo! We don't have a node modules folder anymore.
But there are other folders.
Pardon?
But there are other folders.
Yeah, there's a bin and an object folder, but bin and object, they don't contain, I don't know, 20,000 files and have 200 megabytes. This is not the case anymore. Okay? So, let's go back to the homework. Anything else? No, you have to adhere to the specification here, and yeah, that's it. If you would like to host your web application on the internet, there is a great service there, which is called Azure App Service. It's from Microsoft too. You can follow the link that I gave you here. The good news is that Azure App Service, it's so cool to host web APIs there. It's really, really nice. It's super simple to publish APIs to there. And Azure App Services has a free tier. And not only free for 30 days, but really free as in free continuously. You can host up to 10 web APIs per data center forever, free. Yes, there are some quotas concerning memory limit and CPU limit, and they have a lot of data centers, though I think there are 4 or 6 in Europe, so you can host a lot of services there. It's not part of the mandatory homework, it's just for those of you who would like to try it. As a student, with your student accounts, you should be able to get an Azure account for free without a credit card. Yeah. And the app service stuff is really for free. You don't need a credit card for that. Yes, that's essentially it. Today in the afternoon, we don't have a lesson because there is a schulinterne Lehrerfortbildung, so all the teachers are occupied. And next week, I will be absent. So next week, I guess you have cover lessons, Supplierstunden. Please tell the teacher that comes to your cover lesson that you got an homework from me, and I'm perfectly fine if you spend the lesson next week to work on this homework. So maybe that makes it easier for you to fulfill this homework. This homework is up until in 2 weeks. It's super important, I cannot stress that enough, to make this homework. Because in a few weeks, rather early this year, we have a written exam. And of course, in this written exam in mobile computing, you will need to write a web API like this. So if you finish this homework successfully, you have finished half the necessary preparation for this test, okay? So please don't skip this homework. I know it's early in the year, but this homework is really important. Good? Do you have any questions regarding the homework or the ASP.NET stuff? How do you like it compared to what we have done last year in Node? Good? Yeah, I see one thumb up. Yep, I see some nodding heads. In Visual Studio, it makes it simpler to come up with the project. The configuration is simpler, and the debugger, just press F5 and it works, is also simpler. If you don't like Visual Studio and you would like to use Visual Studio Code, that's perfectly fine. If you install, let me show you that, the C# plugin in Visual Studio Code, this one, you can nearly work with the same productivity as in Visual Studio, but not completely. So if you have an, I don't know, allergic reaction to non-open source products, use Visual Studio Code. It will be not as convenient as with Visual Studio, but it's completely open source, completely free, and completely platform neutral. So if that's important for you, give it a try. It really works well. Good. With that, we are done for today. Thank you, and I see you in 2 weeks. Thank you.